In this application-oriented work, we break down the molecular technique into very challenging agricultural domains, where we demonstrate a sound system which can be used in various agricultural tasks, like precise farming, field monitoring with the field robotic. To the best of knowledge, we are among the first who successfully present the evaluation result of visual SLAM with only a single camera. The motivation is clear that agricultural scenes are considered as one of the most difficult scenarios for visual SLAM and 3D reconstruction. With a molecular image sequence, it is not easy to reconstruct a 3D model from it. Due to the difficulty of repetitive patterns, the camera is shaking all along with the robot, the illumination changes because of sunshine, and environment is not rigid. Here you can see the example image from dataset Rosario. So with preliminary experiments of default orb SLAM 2 and a state-of-the-art structure from motion pipeline core map, the problem lands on the system not able to find the first two best views to initialize, and the tracking or the image alignment is difficult due to repetitive patterns, which results in wrong feature matching. However, in this work, we explore the possibility to make the molecular SLAM works on such data sequences with very simple and efficient modifications to the SLAM system. First, we changed the threshold that SLAM used to pick between the fundamental matrix and the homography. It is obvious that planar structures do not dominate the image like man-made environment, so we pick the fundamental matrix more. And far points are masked out because it provides wrong orientation information, and more feature points are extracted to boost motion model-based tracking within the SLAM algorithm. As long as tracking works, we are able to provide a proper pose graph for either offline dense reconstruction or real-time dense reconstruction. For offline dense reconstruction, we modify the original pipeline of core map, while we first run the SLAM on the dataset to find neighborhood information between images. Then we import the keyframe pose graph into core map with geo-registration of the camera center of the image. So the position of the camera center is registered with absolute coordinates using GPS measurement. In this way, we reconstruct dense point cloud up to real scale, and it is ready for geometric analysis. For real-time dense reconstruction, we integrate remote into our pipeline. We show that point cloud generated in real time is good enough for tasks like auto steer. Further, it is very interesting to evaluate unsupervised depth estimation on such agricultural dataset, while most of current works are focused on datasets like Kitty. Along with molecular SLAM, we are able to simulate RGBD SLAM to tackle the scale ambiguity. Since there are stereo image sequences available from the dataset, we train the monodepth 2 on the image sequence of right camera and evaluate depth estimation and simulate RGBD SLAM on image sequence of the left camera. So please find more implementation details and results in our paper. Thank you for your attention.